So you've been completing the square, and you've been doing problems on worksheets and problems on warm-ups, and you've just found your negative b over 2 or your b over 2 squareds over and over. Well, when you do the same system over and over and over, always follow the same process. What you could do is, instead of solving with numbers, solve with letters. In the process of solving an equation with letters instead of numbers, you work with what's called a literal equation, but you can make a formula. So I'm going to complete the square with ax squared plus bx plus c equals 0. And I'm going to do this rather quickly. The first step when completing the square is to subtract c from both sides, which in this case is a literal c. The next step is to divide everything by a, which in this case is a literal a. So we have x squared plus b over ax equals negative c over a. Now I want to find b over 2 squared. Well, this gets a little bit weird, because right now my b term is actually b over a. That's what this was here. So that means if b is b over a, then b over 2 is really b over 2a. And b over 2 squared is actually b squared, I square the top, and 4a squared from squaring the bottom. So I'm going to add a b squared over 4a squared over here. Now the left side can factor. The left side always factors into x plus b over 2, and we know what b over 2 is. It's b over 2a. So this is going to become, I'll go back to yellow, a better yellow, x plus b squared, no, sorry, b over 2a squared. And over on the other side, I want to get a common denominator. So I'm going to multiply the top and the bottom by 4a. I'm going to multiply this by 4a on top and 4a on the bottom to get a common denominator. So I have minus 4ac plus b squared over 4a squared. I'm now pretty close to completing the square with this puppy. I'm going to square root both sides. Lots of colors going on. And I get x plus b over 2a equals plus or minus. I'm going to rearrange the top up here. I'm going to make this look like the square root of b squared minus 4ac. And on the bottom, the square root of 4a squared is just 2a. Now I subtract b over 2a from both sides. And we get x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. And please notice this right here is an AOS. Negative b over 2a is how you find an AOS. Now we put all this together and make it look pretty, and we get x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, and boom! We just found a formula that can solve quadratics. What should we call that? Oh, I know, let's call it the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. It feels kind of inelegant. A lot of math formulas work out really clean and simple and pretty, and that one feels clunky. But that doesn't make it any less wonderful. And in fact, the fact that it has a negative b over 2a kind of embedded in it is pretty interesting and useful and exciting. But now we can basically complete the square without following the steps of completing the square, because we did it one time as a formula. And now I can solve. So here, a is negative 3, b is negative 5, c is 8. I'm going to do negative b, right, negative b, which is 5, plus or minus the square root of negative 5 squared, because it's b squared, negative 5 squared is 25, minus 4 times negative 3 times 8, all divided by 2a, which is going to be negative 6. This gets me my x value. Please, please, please be careful with two pieces here. One thing people miss is this division is covering everything. The last thing I will do is divide by negative 6. It's always the last step. Please don't mess that up. But secondly, people kind of forget their algebra and struggle with how to handle this part in here. I recommend you think of this as negative 4 times negative 3 times 8. Which is 12 times 8, which is 96. It's a positive 96, because the negative times the negative gets you a positive. So it's 5 plus or minus the square root of 96, sorry, 25, yeah, 25 plus 96. All divided by negative 6. And 25 plus 96 is 121. Luckily, 121 is a perfect square. It's 11. This is 5 plus or minus 11 over 6. So we get answers of 16 over 6, which is 8 over 3. And we also get negative 1. Those are our solutions. Again, those numbers are pretty clean. They're integer fractions or integer values, meaning this could have been factored. But that's okay. There is your quadratic formula. I completed the square. It just doesn't look like I completed the square. Please note, it only works if it's equal to 0. If you get an equation that wasn't equal to 0, set it equal to 0, and then do the quadratic formula. And something else kind of comes out of this. We can now see really clearly that there's this square root with something happening inside of it. And the fact that there's a square root in this formula makes it easy for us to tell if there's going to be solutions or not. Like if b squared minus 4ac works out to something negative, if this is something negative, at some point we would be square rooting a negative, which we know we can't have a real solution. We have the imaginary solutions, but not a real one. So if b squared minus 4ac is negative, that means we don't have any roots anywhere, because the quadratic formula is finding roots. This is called the discriminant. The discriminant is the b squared minus 4ac part of the quadratic formula. In a previous chapter, we learned about determinants. That was a matrix thing. This is different. This is discriminants. You take the b squared minus 4ac part of the quadratic formula and determine how many solutions there will be. So before you start a problem, you can tell if it's solvable and in what way it's solvable. Are there 2 real solutions? Is there 1 real solution? Or is there no real solutions? If b squared minus 4ac is positive, there's 2 solutions, 2 real solutions. If it's 0, there's 1 real solution, the same solution twice. And if it's negative, then there's no solutions. There's 2 imaginary solutions. So right now, before I do the quadratic formula here, I'm just going to calculate the discriminant. b squared minus 4ac would be 16 minus 4 times 3 times 5, which is 16 minus 60, which is negative 46. So this has no real solutions. It has 2 imaginary solutions. Well, okay, I can still find the imaginary solutions. And here's the nice thing about the discriminant. I was going to do it anyways. Like, I'm going to have to calculate it at some point anyways in the process. So just always do it first. Now I'll write negative 4 plus or minus the square root of negative 46, all divided by 2a, which would be a 6 in this case because I skipped all this, but a is 3, b is 4, c is 5. Can 46 break down? That's 2 and 23. That's prime. So 46 is a prime number. So my solutions I would write as x equals negative 4 plus or minus I root 46 over 6. And since we like imaginary numbers to be split up into parts, I would write negative 4 over 6 plus or minus I root 46 over 6. And negative 4, 6 is negative 2/3. Imaginary solutions. Beautiful. So, how many solutions does this quadratic have? Well, I'm going to calculate b squared minus 4ac, which is 16 minus 4 times 2 times 2, which is 16 minus 16, which is 0. The discriminant came out to 0. And since the discriminant is 0, I know that means that there's 1 real solution. It's actually the same solution twice. Whenever this happens, it means that you have a parabola that's exactly, the vertex is exactly on the x-axis, somewhere, somehow. So now we find the solution. I'll do negative b plus or minus the square root of b squared minus 4ac, which I just calculated. b squared minus 4ac was 0, all over 2a, which is going to be 4. So this is negative 4 plus or minus 0 over 4, which is negative 4 over 4, which is negative 1. That's the only solution. Negative 1. X squared minus 2x minus 5 equals 5. Quadratic formula only works when you're equal to 0. B squared minus 4ac would be 4 minus 4 times 1 times negative 10, which is 4 plus 40, which is 44. So the solution is going to be, this is my, I'm going to do negative b plus or minus the square root of b squared minus 4ac all over 2a. This 2 and this 44 can't divide, because one's inside a square root and one isn't. And this 2 and this 2 can't divide or cancel, because I can't just do part of it, I've got to do all of it. So if I want to try and cancel these 2's, first I've got to simplify 44. 44 is 4 and 11. 4 is a pair of 2's, so a pair of 2 comes out. So now I have 2 plus or minus 2 root 11 over 2. Now all these 2's can cancel. 2 divided by 2 is 1. It's 1 plus or minus root 11. Covered that fast, but yeah, we've learned how to simplify before. Now we're just plugging in numbers and going for it. When you are doing the quadratic formula, you're finding the roots. And when you're factoring, you're finding the roots. And when you're completing the square, you're basically finding the roots, although it can kind of be thought of differently. I'm going to first graph this. Okay, so the AOS is negative b divided by 2a, which is 2. If I do f of 2, that gives me the vertex. 4 minus 8 is negative 4, plus 3 is negative 1. This is a vertex at 2, negative 1. Yep, I'm going to draw on some axes here. This graph is pointing up, so I want to give myself lots of space to go up. So, 2, negative 1 is here. Roots are at... I don't know where the roots are yet. I actually do. They're going to be here and here. Let me show you how I know that. I'll do the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c. So this is 4, all divided by 2a, excuse me. This is 4 plus or minus the square root of 4, all divided by 2, which is then 4 plus or minus 2 over 2. Now I could simplify this and make it 6 over 2 and 2 over 2. But before I do that, I want to think about this in terms of its two pieces of a fraction. That's the same as 4 over 2 plus or minus 2 over 2. I just split the top up into two different fractions. This number here is the AOS, because in the quadratic formula, that was a negative b over 2a. This number here is how far left or right you travel to get from the AOS to the roots, because the roots are here and here, right? This comes out to, like if I do this 4 plus or minus 2 over 2, that becomes 6 over 2 and 2 over 2, which is 3 and 1. The roots are at 3 and 1. The AOS was here. But this distance of 1 and this distance of 1 is the distance from the AOS to the roots. This gives you the distance from the AOS to the roots. And that little distance piece inside the quadratic formula can be really useful in certain situations and problems. So when you're doing the quadratic formula, understand you're really completing the square and you're finding the AOS, and then you're traveling a distance from the AOS left and right. So in the quadratic formula, this right here is the line of symmetry, but then this right here is how far to travel from the line of symmetry to get to your roots. And I should really grab that plus or minus because it goes left and right. One goes left, one goes right. Okay, calculator. When you type this stuff into your calculator, you have to be very, very careful of parentheses. If I do, if I just kind of take this and type it in the way that it looks, 4 plus, I can't do plus or minus, so I have to do it twice. 4 plus the square root of 16 minus 4 times 1 times 3 divided by 2. Then I get an answer of 5 that doesn't actually work. 5 is not a solution. 5 squared is 25, minus 20 is 5, plus 3 is 8. 5 doesn't work because you have to think like a machine. This calculator is doing the order of operations, which means the first thing it's going to do is 4 times 1 times 3. then it does 16 minus whatever that was, then it does the square root of whatever that was, and that's all okay. But the next thing it'll do is whatever this number was divided by 2, then it will add 4 last. We don't want that. We have to think like a machine. Everything on top of this fraction has to be in parentheses. 4 plus the square root of 4 squared. I never type the 4 squared, I just do it. 4 squared is 16. Minus 4 times 1 times 3. Double close parentheses. Then divided by, if I was going to multiply something down here, like if I had to do 2 times a, that also has to go in parentheses. There is one of my solutions of 3. Press second enter to pull up the previous expression. Go back and change the plus to a minus. There's my other solution, 3 and 1. And if you're really fancy, you can be like me and just program it into your calculator. Quadratic form, what's the a value? A value is 1, b value -4, c value 3. Boom. Solutions are 1 and 3. So you can have goals and dreams and be just like me, which really is what everybody should hope for. Hey, thanks for watching. I hope that was helpful. If you have any questions, leave them in the comments down below. There can be questions about the video you saw here or anything else in math I'm happy to help with. Subscribe if you'd like to watch more videos or see other updates as they come. I'm going to try to run through all of Algebra 2 Trig and then eventually hit more classes like Algebra 1 and Geometry and Pre-Calc and everything else. If you have questions about stuff covered that's not in this video, still let me know. I'm happy to help. And finally, if you're not one of my students taking the class, but you found the video and are watching it, or maybe you're a teacher and are watching it, you can buy the curriculum and buy the worksheets to go through it. That's found at the website listed down below also. So again, thanks for watching. Have a wonderful day.